This lesson is on solving multi-step inequalities. So we're going to do some review about basic inequalities, just one step kind of inequalities here, and then you may have seen this foldable before in 7th grade. We're just going to talk about the order of inequalities, and then we're going to dive into another foldable that's about solving multi-step inequalities, with variables on both sides. So let's start with just showing how to cut each one of these. So this one you're going to want to fold this way, as close to the middle as you can get it. And then you're going to open it up. So we want to be able to fold each of these flaps open. So what you're going to do is take your scissors and cut along the dotted edge. And you'll just do that for the other 3 lines and be able to have its own little section. The other one is the flip-flop foldable. You have 2 of these per page and you only need 1, so go ahead and cut down the middle. If you want, what you can do is fold it first so you can get a nice straight line. And then once you have that straight line, just cut it right down the middle. And you have one more that I've actually already started to write in, but you have this one blank, and you're going to again fold it in half just like the flip-flops, because you only need 1 copy, and then one's for if you make a mistake. I'm going to go over these and the directions so you don't have to pause the video and write this down, because we're going to do that in a little bit. Now I started writing in mine, but this is what we're going to start with, is this foldable here. What I want you to do is start with the outside. So we're going to just briefly review these symbols and what they represent, and then examples on graphing the symbols. So the first one is going to be the less than symbol. So for example, if we have b is less than 4, what I'm going to do is circle 4, and I'm going to shade towards those values that are less than 4. In this case, I'm shading this way. So I'm going to shade these values here. So now we have to talk about the circle. We've shaded everything less than 4, but what about 4? Is 4 less than 4? And it's not. So that means that this circle that we put around 4 should be open, because it does not include 4 as part of the solutions. And let's close that one, and we'll go to less than or equal to. An example of less than or equal to is e is less than or equal to 8. So we're going to start on 8 and put a circle. Now what I like to do is, instead of this one where I put it right on the line, I actually like to go above the line and do my shading above so it looks nicer. Now less than or equal to 8, so I'm going to be shading this way. And again, you have to ask yourself, does it include 8? Is 8 less than or equal to 8? And it is. So the way I like to show this on graph and describe it is, think of the line representing the answers going through the circle so that it's with the 8, because it has to include that value. So the point of shading when we graph inequalities is to show all the possible solutions. So don't get so caught up in, if it's a line underneath, it means it's equal to, yada yada. just think about, if 8 works, do I want to show that 8 works? If you do, then you have to show that it's shaded in. So next we'll go with the greater than symbol. So A is greater than 5. So I'm going to circle above 5. And it's going to be all those values that are greater than 5. So I'm shading towards the right. And does it include 5? It does not. So I have to show that by leaving that open. So this one is open. Actually, go back here because that should be closed. So next we're going to do greater than or equal to. And I threw in a negative here. So Z is greater than or equal to -3. So we have the circle on -3. And we're talking about values greater than or equal to -3. And values that are greater than -3 are going to be all these ones to the right, right? -2, -1, 0. So using negatives in graphing can trip people up sometimes. They think if it means that it's greater than -3, then -4, -5, -6. Because 4 is bigger than 3, and 5 is bigger than 3, and 6 is bigger than 3. But you can't think that way. What's greater is kind of you don't want as many negatives when you think about greater values, right? We don't like to be in the negative. So having less negatives, like 2 negatives or 1 negative, is actually a greater value for you. So you can kind of think of it that way if it helps. So Z is going to be these values that are greater than -3. And since it includes -3, it's going to be a closed circle. And then lastly is not equal to. Now this one you don't really see that often, but how could we graph x does not equal 12? So we know we're talking about 12, so we're going to put a circle above it. And what values would work? Could x be 11? Could x be 10? Could x be 9? Right? All of these values are going to work except for 12, because 12 cannot equal 12. So in this case, I am shading everything except for, right, this open circle here. And then there should also be a closed circle. So you can go ahead and tape or glue this one into your interactive notebook. To tape it in, what I do is I just open it up and then put a piece of tape here and then along the bottom, and then even along the side if you want, so that it stays in place but still flips open. And turn the page, we're going to talk about how the order of inequalities matter, the order in which you write inequalities. So this is a new page with a new foldable. And when you're working with inequalities, the order matters because you want to read it from left to right, just like in English we read from left to right. So when we have an inequality like this, we want it written as the variable, then the inequality symbol, and then the constant. So when you read this, it reads x is less than 7. And if it's backwards, what you have to do if you're trying to explain this to somebody is you would have to read it backwards, which is just more work. So whenever you write an inequality and give your answer as an inequality, you want to have it written left to right with the variable, then the inequality symbol, and then the constant. So what happens if it's not left to right? if you have to flip-flop the sides of the inequality, then you must also flip-flop the inequality symbol. So let me show you what that looks like. Let's say we have written down 7 is greater than x. And to write that as an inequality, we write the 7 and then the greater than symbol and then x. But graphing that's going to be difficult. Right? We're trying to talk about x, the values of x that work, not the values of 7. So we want to start with x. In order to flip-flop that, okay, I have to say that x is less than 7. So I'm switching their places, but I'm also flipping the inequality symbol. And I like to think of this as just reading it backwards. So if you have 7 is greater than x, think of it as like a mirror. So let's read it right to left so we can write it down correctly. That would mean that x is less than 7. And this foldable is just going to go right in your next page so you know that this is what we do when it's unordered and we have to put it in the right order. And you can just put a piece of tape on the top and on the bottom or on the sides. And flip to a new page. This is going to be our last handout to put in your book. And we talk about solving and graphing inequalities with one variable. So we're going to solve inequalities just like this, similar to the way we solve equations. Kind of steps are similar, right? But now instead of a singular solution, we have a range of solutions. So let's start talking about the steps that are involved in that. First, though, we have the golden rule of inequalities. This is one you may have seen in 7th grade, but whenever you multiply or you divide both sides of an inequality by a negative number, you must flip the inequality symbol. So whenever you're multiplying or dividing by a negative number, you have to flip it. Now, when you add or subtract, you don't have to flip it. It's just multiply or dividing. So our first step is to get the variable by itself on one side of the inequality symbol. And we can think about different ways of doing this. I could move this 3x over here, or I could move this x over here. Either way I do it, if I do all my math correctly, I should end up with the same answer. One way might be longer than the others. When I think about inequalities, I know that I want it written in order, right, with a variable on the left, symbol, and then a constant. And constant just means it's a number. So I'm going to try and move this x over here so it's all lined up. My first step is going to be subtract an x from both sides. And I have 5, and then minus 4x is still less than or equal to 13. Zoom in a little bit. And those cancel. So now I want to move the constants to the other side, so I'm going to subtract 5 from both sides. This is just like when we solve equations, right? 5 minus 5 is 0, so I have negative 4x is less than or equal to, and 13 minus 5 is 8. So still the x is not by itself, right? So I've got to divide by negative 4. And then those cancel. I'm left with x. Now, because I divided by a negative number, I have to use the golden rule. and flip it. So this means that x is going to be greater than or equal to 8 divided by -4, which is -2. Now after I've gotten x by itself, I'm going to check the order. So does it go variable, symbol, constant? Variable, symbol, constant. It does, so I'm all set there. Now I want to circle the number on the number line. So I know we're talking about -2, so I'm going to put -2 in here. And to finish out the number line, -3, -4, -5. So I'm putting a circle on the number line. You can put it above if you wish. I like to put it above. Now, is it an open circle or is it a closed circle? So the open circle, those inequality symbols are your less thans, your greater thans, right, and your not equal to. Closed circle are going to be the less than or equal to, greater than or equal to, and then just equal to. So for this one, we have a closed circle. And that last step is to shade appropriately. So I want values that are greater than -2. Those are over here. Now some of you like to take a shortcut, and it's a great shortcut if it's written correctly. These inequality symbols kind of look like arrows. So if I have an arrow that looks like it's pointed to the right, then I'm going to shade to the right, almost like you're copying down that arrow. And you can also kind of think of this bar here as your line that goes through the circle. So that's one way to think about it. Now it doesn't work if it's not written correctly. For example, if we go back here, if 7 is greater than x, and I want to graph that, well then I should have an arrow pointing to the right. But really, if I'm graphing it correctly, because x is a value less than 7, it should go to the left. So that's why it really only works if it's written in order. If it's not written in order, that trick isn't going to work. So for best practice, always make it go variable, inequality symbol, and then constant. After you tape that one in on the sides and on the top, or top and bottom, you are going to do these 3 on your own problems and have your teacher check them for you. So I'll read them out to you. That's 3 times the quantity x plus 1 minus 4x is greater than or equal to -5. Number 2 is 6m minus 1 is less than 3m plus 8. And the third and final one is -4 is less than or equal to 4 times the quantity 6y minus 12 minus 2y. When you're finished with those 3 problems, have your teacher check your answer, and you can move on to the practice from the textbook.